Hey guys, we're back again with another video in the Passive Crossover Designer series where we teach you how to design crossovers in Jeff Bagby's software. Now, let's go ahead and what we're going to show you today is how to make an MTM, and also we're going to show you a little bit about notch filters. So let's go ahead and load the woofer FRD like we would typically do. Now we're going to use the mid-range. We're going to use the Dayton DC 130B-8. First thing we're going to do is open up that file, both the FRD and the ZMA. Now once we load that up, we're going to scroll down just a little bit down the page where it says second woofer FRD and ZMA, and we're going to add that as well. And that's pretty straightforward so far. Now we're not done. We still need to load our tweeter like normal, and for this particular speaker we're going to go ahead and use the Dayton ND25 FA4, which is a really good tweeter. I really like it. You've seen me use it actually in other projects like the DIY soundbar and DIY Dayton soundbar actually, and a couple other things. So it's just a really nice tweeter. Now we're not finished. Now you would think that we're finished. We have all the stuff loaded, but we're not. And here's the reason why. The program's still only reading one woofer. And the reason why it's reading only one woofer is because we haven't changed the number. So we're going to change that to 2. There we go. Now it says that we have 2 woofers, and we're going to see that change quite a bit. We're still not done. We need to select the wiring. And by doing that, we select this gray button down here. So to change the woofers, we hit it here to leave 1 or 2. And woofer wiring, we're going to hit here, series or parallel. If you're not sure which one you want, scroll down to your woofer impedance. This is saying right now that we are wired in parallel, and in parallel we're at a 4 ohm load. Now if we were to click that and put it in series, now look, we're at a 16 ohm load. So we're going to keep it around a 4 ohm load. And now we're going to go ahead and start designing this speaker. So let's go ahead and pick around a 2500 hertz crossover, and actually let's do 3000. Let's just do a 3000 hertz crossover, and let's take a look at what we got so far. Okay, the crossover looks pretty terrible. I mean, if we got to be honest, it just looks bad. And there's a couple reasons for doing that. Now click on driver response. We're going to see, of course, this once again is just crazy. I'm going to do 2500, and then what I'm going to do is I'm going to put a Zobel in there to try to work on that. And that worked quite a bit. Still not perfect. And here's the reason why. You got a couple things going on here. So let's take a look at this crossover. You'll notice, one, this tweeter is going down pretty slowly. And because of that, it's actually bumping up this region. So you can see that both of these are still being added in this region, and that's not good. We want everything to be, right around this 85 hertz, minus maybe this here, which would actually be kind of good for our baffle step. So we got to take care of that. Now let's start bringing this inductor down. If you move this inductor down, what you're going to notice is that these start changing. And we'll bring it down to about, there we go. And let's see. All right, now see, it's already looking much, much better. However, we still have these 2 bumps, and that's a problem. So what we want to do is change the notch filter. Now what we could do is lower everything, but since we know the basic premise of a baffle step is that the lower region is going to be about a 6 decibel loss once you put it actually in a baffle, what we would probably be more beneficial doing right now is to lower this via a notch filter. Now you have all kinds of options, and once you actually build it, you can really determine if that was the best thing to do or not. But let's show you how to do a notch filter right now to show you how to get this back in line. So what we're going to do is we're going to go to the web, and we're going to type in a couple things. Now we know that our speakers are both 4 ohm, and we want to look to see where we want to start this notch filter at. Now most people are going to look at it and say, okay, well the problem area is really right here. We're going to want to start it right around 3,000. That would be a mistake, and we'll show you why. We'll actually do it so that you can see. So let's go 3,000 hertz. We're going to calculate the first order crossover, which is about a 0.21. Oops. And we will put that right here. This is a series crossover. We're going to create an LR crossover. So we're going to go 0.21, and then we're going to actually add a resistor. Now a resistor will then lower whatever frequency that you started at. So the first frequency that we started at was 3,000, so we'll add a 4 ohm resistor. Now see, that dropped it, but you see how it really didn't do enough in this region. Now we could add more, like we could bump this up to 20, for example, and you see it's not doing enough, and that's because we started it too late. Like, we really want this down lower. So what we can do instead is increase the inductor. Now increasing the inductor starts this earlier. So if we increase this, let's try a 0.43, for example. So let's increase that, and now look at that. If we take a look, now everything is in line. Now that's what a notch filter will do. A notch filter, when you have something like this going on with the woofer, you can just use a notch filter. You might even be able to get rid of a zobel by doing that, like not needing the zobel. In this particular case, we cannot, unless we really did a lot of work with that, which we're not going to do that. So that's an option that you always have. But now you take a look at it, it's a very even linear response, and you start going up a little, and about 300 hertz or so, you're starting to get a bump. And then of course this will be extended to wherever your box is. This is why I like Chev boxes, because it should keep everything right around that 95, which is about a 5 decibel increase in bass, and that's typically right about where you want to be for a baffle step loss. So that would actually be a very nice even speaker when you're finished, assuming that all of these FRD and ZMA files are pretty good. Alright guys, I hope you learned something. I hope you learned now how to import and do an MTM, and also a little bit about notch filters. If you want me to explain notch filters more, we can do that again. And in fact, I plan to do one on RLC, so maybe I can do one on RLC and LR if you want to. Just give me an idea of what you might want to see, and we'll make sure to implement it. All right, guys, if you enjoyed this, please give it a thumbs up, subscribe, and as always, like the video. Thanks, guys.